In this session, we will try to understand how Oracle ASM operates behind the scenes. First, let us discuss about Oracle ASM storage components. Oracle ASM disks are the basic storage devices which can be added to Oracle ASM disk groups. Oracle ASM disks can be one of the following: a disk or a partition from a local disk or a storage array. It can be a logical volume or a network-attached file. On Linux operating system, disks from storage array are presented to the system as logical unit numbers. Oracle ASM supports disk multipathing. Oracle ASM disk group is a collection of one or more ASM disks. Oracle ASM disk group is managed as a single unit by Oracle ASM. Oracle ASM disk group is comparable to a volume group in Logical Volume Manager. Oracle ASM provides a file system-like interface for storing Oracle database files in ASM disk groups. By default, Oracle ASM distributes file contents evenly across all disks in an ASM disk group using striping techniques. Oracle ASM also provides data redundancy using built-in mirroring algorithm. Disk group name is preceded by a plus sign. You can think of the plus sign as the root directory of Oracle ASM file system, similar to / in Linux operating system. A disk group might contain database files belonging to several databases, and a single database can use files from multiple disk groups. Oracle ASM allocation unit is the fundamental unit of allocation within a disk group. Allocation unit is the smallest contiguous disk space that Oracle ASM allocates. Every ASM disk is divided into several allocation units. Allocation unit size can be selected during creation of an ASM disk group. Allocation unit size cannot be changed after creation of an ASM disk group. Allocation unit can be of various sizes depending on ASM disk groups compatibility setting. Larger allocation units can provide higher performance for larger sequential reads in data warehouse applications. Oracle ASM extent, also called as data extent, is the raw storage used to hold the contents of an ASM file. Each ASM extent is a collection of one or more allocation units from a specific disk. Oracle RDBMS stores database files on a file system. When Oracle ASM is used, database files are stored in Oracle ASM disk group, and those files are called Oracle ASM files. Oracle Database communicates with Oracle ASM in terms of files. Currently, Oracle ASM supports only database-related files, such as control files, data files, temporary data files, data file copies, server parameter files, online, redo log files, archive log files, flashback logs, RMM backups, disaster recovery, configuration files, change tracking, bitmap files, data pump, dump sets. Oracle ASM file consists of one or more ASM extents. Oracle ASM file is completely stored only in one disk group. Note that Oracle ACFS ASM cluster file system can store non-database files. Oracle ASM File Extend Map is a list of extend pointers that point to all the data extents of a file. Each extend pointer contains the disk identification, allocation unit number, and checksum information for the data extent. When Oracle Database sends a request to open an ASM file, Oracle ASM provides ASM File Extend Map to the database instance. Database instance keeps this ASM File Extend Map in memory, and there onwards, database performs input-output directly to ASM files in ASM disk groups. Now, let us understand the relationship between each of these Oracle ASM storage components. One ASM disk group can contain one or more ASM disks. At any given time, a specific ASM disk can belong to only one ASM disk group. Each ASM file is completely stored only in one disk group. A disk group might contain database files belonging to several databases, and a single database can use files from multiple disk groups. Every ASM disk is subdivided into several allocation units. Each ASM extent is a collection of one or more ASM allocation units from a specific ASM disk. Each ASM file is a collection of one or more ASM allocation units from a specific ASM disk group. To handle large files efficiently, Oracle ASM uses Variable Size Extents feature. This feature is only available for disk groups with RDBMS compatibility set to 11.1 or higher. When new ASM file is created, extents are allocated using following logic. First 20,000 extents are of 1 allocation unit size. Next 20,000 extents are of 4 times allocation unit size. All extents beyond 40,000 extents are of 16 times allocation unit size. Variable Size Extents feature handles large files efficiently and reduces system global area memory requirements for very large databases. This feature improves performance for file handling operations. Now, let us understand how Oracle ASM instance is started by Oracle Clusterware. Note that this is only a partial diagram to show Oracle ASM related startup steps. Several other required components are not displayed here and not discussed here. During Oracle Clusterware startup, initialization process starts Oracle High Availability Services daemon OHASD. Oracle High Availability Services daemon then starts ORA agent and ORA root agent processes. ORA agent starts Oracle ASM process. Meanwhile, ORA root agent starts Cluster Ready Services daemon CRSD. Then, CRSD, using ORA agent, will start Oracle ASM instance. Oracle ASM instance will establish communication with Oracle ASM process. Now, Oracle ASM instance is up and running. Now, ORA agent can start database instances. Now, let us take a look at how we can start up and shut down Oracle ASM instance using SQL+. We can start up and shut down Oracle ASM instance while logged in as Grid Infrastructure Owner or Grid User. We have to log into SQL+ using sysASM privileges. Notice that I am running Oracle 12c, Release 1, version 12.102. Oracle ASM instance can be started using startup command. First, Oracle ASM instance is started. System global area and other memory structures are allocated. Oracle ASM background processes are started. Oracle ASM disk groups are mounted. Note that Oracle ASM instance does not mount or open any database. If Oracle ASM instance is up and running, it can be shut down using Shutdown Immediate command. Oracle ASM will wait for any in-progress operations to complete. During shutdown, first Oracle ASM disk groups are dismounted. Then Oracle ASM instance is shut down. If any database instances are still connected to the Oracle ASM instance, then the shutdown command returns ORA 15097 error and leaves the Oracle ASM instance running. Oracle ASM stores metadata to describe the contents of Oracle ASM disk groups. All the metadata related to a disk group is completely stored within the same disk group. Each disk group has physical metadata and virtual metadata. Oracle ASM physical metadata is located on each disk at a fixed location. Oracle ASM physical metadata contains 4 metadata structures: disk header, allocation table, free space table, and partnership status table. Oracle ASM identifies each ASM disk using its disk header metadata. Disk header is located at the first block of the first allocation unit on each ASM disk. Metadata in the disk header is very specific to each individual disk, and disk header is not mirrored on any other disk. Disk header contains information such as disk name, disk number, disk group name to which the disk belongs, failure group name, disk size, allocation unit size, disk group creation timestamp, disk group amount timestamp. If 2 ASM disks claim to have the same disk number and disk name in one disk group, then disk group creation timestamp and disk group amount timestamp information is used to identify the correct disk while mounting the disk group. ASM compatibility version dictates the minimum required Oracle ASM software version to mount the disk group. ASM also stores this version number in partnership status table. RDBMS compatibility version dictates the minimum required Oracle RDBMS software version to access the disk group. this information is not used because Oracle RDBMS software queries attribute directory for this information if ASM compatibility version is 11.1 or higher. If disk contains the file directory, then the file directory pointer points to the first extent of the file directory. File directory is a part of Oracle ASM Virtual Metadata, and it will be discussed later in this session. Storage vendors who develop ASM lib can store limited information in ASM lib block. Oracle ASM lib stores disk label in this space. Next, Oracle ASM physical metadata structure is allocation table. Every disk has an allocation table to keep track of allocated space and free space in the disk. Allocation table is stored right after the disk header. Allocation table contains allocation table entry for every allocation unit in the disk. If allocation unit is used by an Oracle ASM file, then its corresponding allocation table entry contains the ASM file number and extend number. Allocation table entries for non-allocated allocation units are marked as free. These free allocation table entries are kept in a linked list to quickly find a free allocation unit. In Oracle 11G Release 1 or higher versions, ASM can keep track of unusable allocation units by keeping a flag in allocation unit entry. Note that ASM will flag unusable allocation units only in normal redundancy and high redundancy disk groups. Collection of 64 allocation unit entries are called an allocation table block. In most cases, an entire allocation table can fit in one allocation unit. But it is possible to have more than one allocation units for a large allocation table. Next, Oracle ASM physical metadata structure is free space table. Free space table contains information about which allocation table blocks contain free allocation units. Oracle ASM uses this information to quickly locate free space in a disk. Next, Oracle ASM physical metadata structure is partnership status table. Partnership status table keeps track of disk group membership and disk partnerships. Oracle ASM uses this information during mounting of disk groups to determine if enough disks are online. Oracle ASM can maintain multiple copies of partnership status table for disk group based on disk group redundancy level. Partnership status table contains information such as partnership status table version number, partnership status table timestamp, partnership status table size, that is, number of disks, number of partnership status table copies maintained for disk group, list of disks containing the partnership status table, ASM compatibility version attribute for disk group. Oracle 11G and above will refer to partnership status table for this attribute. Note that this attribute is also maintained in disk header. Following information is maintained in partnership status table for each disk in the disk group. disk, online, or offline status, for each disk. Number of partners, for each disk. List of partners, for each disk. Partnership status table also maintains disk group heartbeat. This information is used by Oracle ASM to make sure disk groups are not mounted in different clusters at the same time. In other words, this information is used to prevent cross-cluster split-brain scenario. Now, let us discuss about Oracle ASM Virtual Metadata. Oracle ASM Virtual Metadata is stored in ASM files. Oracle ASM Virtual Metadata is subdivided into two types. Metadata directories are stored in ASM files, and they are accessed only by Oracle ASM instance. Metadata registries are also stored in ASM files, and they may be accessed by both Oracle ASM instance and database instance. Because Oracle ASM Virtual Metadata is stored in ASM files, Oracle ASM by default provides data protection using mirroring for these files. For disk groups in normal and high redundancy, Oracle ASM Virtual Metadata is triple mirrored. Oracle ASM does not provide any mirroring for external redundancy disk groups. Note that the $ASM file view will not display any information about Oracle ASM Virtual Metadata. Oracle ASM Virtual Metadata contains various metadata structures. Now, let us discuss about these Oracle ASM Virtual Metadata structures. First, Oracle ASM Virtual Metadata structure is file directory. File directory contains all the required metadata for Oracle ASM files which are stored in ASM disk groups. File number for file directory is 1 in every disk group. File directory contains file number, file incarnation number, file size. Oracle ASM keeps track of both physical space occupied by ASM file in a disk group as well as logical file size as seen by the database. File block size is defined by the database while creating the file. This is not same as ASM allocation unit size or ASM metadata block size. File type is also defined by the database while creating the file. Also, Oracle ASM can identify the file type by looking at the file header. Typical ASM file types are data file, online, redo log file, control file, backup set, etc. File redundancy can be high redundancy, normal redundancy, or no redundancy. Even though redundancy is defined at disk group level, each file can have its own setting for file redundancy. File striping can be of coarse-grained striping or fine-grained striping. File creation time and file modification time. File layout contains a set of extend pointers. This includes direct extents and indirect extents. First 60 extend pointers for a file are called direct extents. Remaining extend pointers for a file are called indirect extents. Next, Oracle ASM Virtual Metadata structure is disk directory. Disk directory contains information about all Oracle ASM disks in a disk group. File number for disk directory is 2 in every disk group. Disk directory contains disk number, disk name, failure group name to which disk belongs, disk size, disk free space information, disk creation time. Most of this information is also available in disk headers. Disk headers cannot be queried when disks are offline. For normal or high redundancy disk groups, after disk group is mounted, disk directory can provide information about offline disks. Next, Oracle ASM Virtual Metadata structure is Active Change Directory. File number for Active Change Directory is 3 in every disk group. Active Change Directory is like redo logs in Oracle database. Active Change Directory is a log maintained by Oracle ASM to track the changes made to ASM data structures. During ASM instance crash recovery, ASM uses Active Change Directory to perform ASM instance crash recovery. Active Change Directory is very important for ASM metadata consistency. Active Change Directory contains file open and close status, a checkpoint which is updated every 3 seconds. Active Change Directory change records for each change made to ASM metadata or ASM data structures. Next, Oracle ASM Virtual Metadata structure is Continuing Operations Directory. File number for Continuing Operations Directory is 4 in every disk group. Continuing Operations Directory is used to track long-running disk group operations. Examples of such operations are ASM disk group rebalance operation or ASM file create operation. In a single instance environment, if ASM instance crashes, ASM can restart disk group rebalance operation based on Continuing Operations Directory entry after ASM instance is recovered and disk groups are mounted. In a RAG environment, if one ASM instance crashes, surviving ASM instance can restart disk group rebalance operation based on Continuing Operations Directory entry. If ASM file create operation fails before database commits the file creation, ASM instance can roll back file allocations based on Continuing Operations Directory entry. Next, Oracle ASM Virtual Metadata structure is Template Directory. File number for Template Directory is 5 in every disk group. Template Directory contains information about all of the ASM file templates in a disk group. When a disk group is created, few templates are created by the system, and they are called default system templates. Later, users can create user-defined templates. Template Directory contains template entry for each template and contains following information: template number, template name. File redundancy can be high redundancy, normal redundancy, or no redundancy. File striping can be coarse grain striping or fine grain striping. System flag indicates if template is system created or it is not created by the system. Next, Oracle ASM Virtual Metadata Structure is alias directory. File number for alias directory is 6 in every disk group. In ASM, alias can be system-created alias or user-created alias. Alias can be system directory or user directory. Alias directory is used to keep track of all the metadata for aliases. Alias directory contains alias number, alias name or directory name, alias incarnation number, ASM file number, ASM file incarnation number, parent directory. System flag indicates if alias is system created or it is not created by the system. Next, Oracle ASM Virtual Metadata Structure is Attributes Directory. Disk group attributes are stored in Attributes Directory. Attributes Directory exists only for disk groups with ASM compatibility set to 11.1 or higher. If Attributes Directory exists, then its file number is 9 in every disk group. Attributes Directory contains entries for Oracle databases 11.1 or higher, and it contains RDBMS compatibility version. Disk repair time attribute specifies the time interval to repair a disk and bring it back online before dropping the disk from the disk group. This was a new feature introduced with Oracle 11G Release 1. Next to Oracle ASM Virtual Metadata Structures are related to a new feature called Oracle ASM Fast Mirror Resync, which was introduced with Oracle 11G Release 1. This feature is only available for disk groups in normal or high redundancy with RDBMS compatibility attribute set to 11.1 or higher. When a disk goes offline, Oracle ASM Fast Mirror Resync feature keeps track of changes to the extents on an offline disk. When the disk is brought back online, these extents are quickly and efficiently resynced using mirror copies. Staleness Directory and Staleness Registry are used for Oracle ASM Fast Mirror Resync feature. File number for Staleness Directory is 12 in the disk group. Staleness Directory contains metadata about the Staleness Registry to map offline disks and Oracle databases which are using those disks. File number for Staleness Registry is 254 in the disk group. Staleness Registry is used to keep track of changes to the extents on offline disks. Oracle Database Instance updates the Staleness Registry during failed writes for an offline disk. Writes are successful if database can write at least one copy to any online disk in the disk group. When the disk is brought back online, Oracle ASM Instance performs Fast Mirror Resync to update all the stale extents on that disk. Note that Staleness Registry is accessed by both Oracle ASM Instance and Database Instance. Oracle ASM stores important information about various ASM components in the form of Oracle ASM, physical metadata, and virtual metadata. All the metadata related to a disk group is completely stored within the same disk group. Oracle database communicates with Oracle ASM in terms of ASM files. Now, let us understand how this communication takes place. First, let us understand how Oracle Database Instance establishes connection to Oracle ASM Instance, and discuss the importance of umbilicus. During Oracle ASM startup, ASM Instance registers itself with cluster synchronization services. First time when Database Instance needs to access an ASM file, it needs to establish a connection to an ASM instance. Database Instance contacts cluster synchronization services with a request for connection string to an ASM instance. Cluster synchronization services provides ASM connection string to the database instance. Now, let us identify the two important processes involved in this communication. On database instance side, ASM background process, ASMB, is started. On ASM instance side, umbilicus, foreground process, UFG, is started. Database instance connects to the ASM instance using operating system authentication with sysdba privileges. Connection between database instance and ASM instance via ASMB and UFG is called umbilicus. Umbilicus remains open as long as database instance has ASM files open. Database and ASM communicate via umbilicus, and it is critical to maintain this connection. ASM background process, ASMB, remains active as long as ASM files are open. When all ASM files are closed by the database instance, ASM background process, ASMB, also exits. Now, let us discuss the importance of cluster synchronization services. During Oracle ASM startup, ASM instance registers itself with cluster synchronization services. When database instance establishes connection to ASM instance and gets access to disk groups, database instance also registers itself with cluster synchronization services. There onwards, cluster synchronization services keep track of database access to ASM disk groups. Cluster synchronization services also tracks the health of processes which can perform file input-output between database and ASM instances. Cluster synchronization services identifies abnormal termination of database instance and informs ASM instance to perform cleanup. Cluster synchronization services plays a critical role in Oracle Real Application Clusters environment. If a database instance crashes, CSS makes sure that all file input-output processes from crashed instance have exited before surviving database instances can perform any recovery. CSS fences off the crashed instance to avoid any data corruption from crashed instance. Now, let us understand how Oracle Database creates an ASM file in ASM Disk Group. When Oracle Database Instance wants to create ASM file, it sends create ASM file request to Oracle ASM Instance. This request contains information such as disk group name, type of file, file block size, file tag, and, optionally, template name and alias name. Using this information, ASM Instance allocates space for a new ASM file. Entries are added to ASM file allocation table, file directory, and alias directory. ASM Instance sends file extend map for the new file to database instance. ASM Instance creates an entry in continuing operations directory to track the pending file create operation. Then, database instance performs required operations to initialize the file. At this point, for any reason, if database aborts the file create operation, then ASM Instance uses continuing operations directory entry to roll back the file creation by removing related entries from ASM file allocation table and by removing file directory entry and alias directory entry. If database successfully completes the file initialization, it sends commit message to the ASM instance. Oracle ASM Instances block writer LGWR flushes the active change directory change records. Oracle ASM Instances database writer DBWR asynchronously writes file allocation table, file directory, and alias directory entries to the disks in the disk group. This is how Oracle Database creates an ASM file in ASM Disk Group. Now, let us understand how Oracle Database opens an ASM file. When Oracle Database Instance wants to open an ASM file, it sends open ASM file request to Oracle ASM Instance. ASM Instance loads file extend map for the file from file directory into its memory SGA. Then, ASM Instance sends the first 60 direct extents from the file extend map to database instance. Database instance keeps this file extend map in its system global area. Using the file extend map, database instance performs any file input-output directly to ASM disks. Note that ASM Instance does not perform any file input-output on behalf of database instance. Initially, database instance gets only first 60 direct extents from the file extend map. If it requires remaining extents map, it will send an on-demand request for indirect extents map. ASM Instance keeps track of all open ASM files to prevent accidental file deletion. Now, we know that ASM Instance sends the file extend map to database, and database instance keeps this in its system global area. Now, let us take a look at how database can open server parameter file, which is stored in ASM disk groups during database instance startup. This is a special scenario because system global area for the database instance does not exist to hold file extend map. Database sends a proxy server parameter file open request via ASM instance. ASM background process, ASMB, is started on ASM instance side. ASM instance establishes a loopback connection to itself. ASM instance reads the required database server parameter file. Contents of database server parameter file are sent back to database instance startup process. Now, database instance can allocate system global area. After database instance is started, it will close proxy connections. Now, database instance sends a regular request to open server parameter file and all other database files. After some time, ASMB process exits. Now, let us understand how Oracle Database closes an ASM file. Database instance sends a request to ASM instance when it wants to close an ASM file. ASM instance cleans up file's internal state. ASM file is now closed. Now, let us understand how Oracle Database deletes an ASM file. Database instance sends a request to ASM instance when it wants to delete an ASM file. ASM instance creates an entry in continuing operations directory to track the file delete operation. If ASM instance crashes, this continuing operations directory entry will be used to complete file delete operation during ASM instance crash recovery. ASM updates allocation table entries for this file as free. ASM releases file directory entries for this file. Finally, ASM removes alias directory entries for this file. Oracle managed files are automatically deleted when the files are no longer required. So, it is a very good idea to use Oracle managed files with automatic storage management. Now, let us understand how Oracle ASM file striping works. For this discussion, let us assume that we have 4 ASM disks in the data disk group. Every ASM disk is divided into several allocation units based on ASM disk group's allocation unit size attribute. When a new ASM file is allocated, it is subdivided into stripes. Each disk will store one stripe from the first stripe set. Then, each disk will store one stripe from the second stripe set. Stripe distribution process is repeated until complete file is stored in disks. Oracle ASM striping provides load balance across all disks in a disk group. Striping also reduces input-output latency. Oracle ASM supports 2 types of striping. Coarse-grained striping is done at allocation unit level. Each stripe size is equal to 1 allocation unit size. Coarse-grained striping provides disk input-output, load balancing, and high throughput. Coarse-grained striping is used for database data files, online, redo log files, backup sets, etc. In fine-grained striping, stripe size is 128 kilobytes. Fine-grained striping provides low latency for small input-output operations. Fine-grained striping is used for database control files. Now, let us discuss about ASM failure groups. Failure group is a subset of disks in a disk group which could fail at the same time because they share common hardware. Failure groups are used to store mirror copies of data. Each mirror copy of data is stored on a disk in a different failure group. Thus, simultaneous failure of all disks in a failure group does not result in data loss. Each disk in a disk group can belong to only one failure group. All failure groups in a disk group should contain same number of disks. It is possible to define failure groups during creation of ASM disk group. If they are not defined, then Oracle ASM automatically places each disk into its own failure group. As you can see here, Data 1 disk group contains 5 ASM disks. Each disk is placed in a separate failure group. It is possible to define failure groups during creation of ASM disk group. As you can see here, Data 2 disk group contains 12 ASM disks. 3 failure groups were defined. Each failure group contains 4 disks. Now, let us understand ASM redundancy options. Oracle ASM provides 3 options for data redundancy. With external redundancy, ASM does not provide any data redundancy. This option should be used when vendor-provided mirroring is in use at storage level. Any write error to disk will cause a forced dismount of the disk group. All disks must be online for disk group to function normally. External redundancy disk group can be created with 1 or more ASM disks. External redundancy disk groups do not use failure groups. Default mirroring level for external redundancy disk group is unprotected. There are no other supported mirroring levels for external redundancy disk groups. With normal redundancy, by default, ASM provides two-way mirroring. All files are mirrored so that there are 2 copies of every extent. A loss of 1 ASM disk is tolerated. Default mirroring level for normal redundancy disk group is 2-way mirroring. Optionally, 3-way mirroring is supported for normal redundancy disk groups. With 3-way mirroring, 3 copies are maintained for every extent. This is high redundancy option. Optionally, it is possible to disable mirroring for some files in normal redundancy disk groups. Normal redundancy disk group requires minimum of 2 ASM disks in 2 failure groups. With high redundancy, Oracle ASM provides triple mirroring or 3-way mirroring. A loss of 2 ASM disks in different failure groups is tolerated. High redundancy disk group requires minimum of 3 ASM disks in 3 failure groups. Note that Oracle ASM virtual metadata is stored in ASM files. 4 disk groups in normal and high redundancy. Oracle ASM Virtual Metadata is triple mirrored. Oracle ASM does not provide any mirroring for external redundancy disk groups. With external redundancy disk groups, when a disk fails, whole disk group goes offline. With normal and high redundancy disk groups, when a disk fails, the failed disk is first taken offline. Offline disk is dropped from the disk group if it is not fixed and not online before disk repair time attribute setting. By default, disk repair time is set to 3.6 hours. Oracle ASM performs rebalance operation on disk group after the offline disk is dropped. With normal and high redundancy disk groups, when a disk fails, the disk group continues to function normally if enough disks are online. Disk group data remains accessible because of mirror copies of data. Failure groups and redundancy level can be defined during creation of disk group. After a disk group is created, redundancy level cannot be changed for the disk group. Remember, for normal and high redundancy disk groups, do not use storage level mirroring provided by storage vendor because that will cause poor performance due to double mirroring. One at ASM level and another at storage level. Now, let us take a look at few examples of data redundancy in ASM disk groups. As you can see here, we have data 1 disk group. This disk group is created with normal redundancy and, by default, it provides two-way mirroring. This disk group contains two failure groups. There are 3 ASM files stored in this disk group, and each file is represented with different color. Each ASM extent in failure group 1 has a mirror copy stored in failure group 2. Note that ASM mirroring is performed at ASM extend level and not at disk level. So, ASM extents can be at different locations in each disk. Now, let us take a look at high redundancy disk group. As you can see here, we have data 2 disk group. This disk group is created with high redundancy and, by default, it provides three-way mirroring. This disk group contains 3 failure groups. There are 4 ASM files stored in this disk group, and each file is represented with different color. Each ASM extent in failure group 1 has 2 mirror copies stored in failure group 2 and failure group 3. Now, let us discuss about Oracle ASM disk group rebalance. Oracle ASM automatically starts a disk group rebalance operation when one or more disks are added or removed from a disk group. It is possible to manually start rebalance operation using SQL command alter disk group rebalance. Rebalance operation moves the data between disks to ensure that every file is evenly spread across all of the disks in a disk group. It also makes sure that disks are evenly occupied. This ensures input-output load balancing across disks in a disk group. It is strongly suggested to have same-size disks assigned to ASM disk groups to get optimal load balancing. disk group rebalance is an online operation, meaning databases can remain online during rebalance operation. ASM creates an entry in continuing operations directory to track the rebalance operation before starting Oracle ASM disk group rebalance operation. If Oracle ASM is in a standalone server mode, and if Oracle ASM instance crashes, then rebalance operation will restart after ASM instance recovery. If Oracle ASM is in real application clusters mode, and if Oracle ASM instance crashes, then rebalance operation will be restarted by any other surviving ASM instance. RBAL background process on ASM instance is ASM rebalance master process. RBAL process initiates and coordinates rebalance activity. RBAL process creates a plan for distributing file extents evenly across the disks in the disk group. ASM power limit initialization parameter on ASM instance specifies the default power for ASM disk rebalancing operation. In other words, it dictates how much power and how many resources will be used for rebalance activity. It is possible to manually change the rebalanced power for a disk group using power clause of SQL command alter disk group rebalance. ARB background process on ASM instance is ASM rebalance process. ASM can start multiple ARB processes to speed up rebalance operation. ARB process relocates ASM extents within an ASM disk group using plans provided by RBAL process. ARB process relocates one ASM extent at a time. So, ASM extent relocation is a short and quick operation. Rebalance operation progress can be retrieved by querying $ASM operation view in ASM instance. If an ASM file is open and being used by database instance, then ASM instance first sends a message to database instance about extend relocation. Database can continue to read data from old extend location. Database will delay new writes to the extent that is being relocated. ASM sends another message to database instance after ASM completes the extend relocation. Database will complete any pending writes to the new extend location. Database can now continue to read and write to the new extend location. This guarantees that no writes are lost during extend relocation. If an ASM file is closed and not being used by the database instance, then ASM can quietly relocate the extents to the new location. Now, let us take a look at an example of Oracle ASM disk group rebalance operation. As you can see here, we have 4 disks in this disk group. Assume that this disk group was created with external redundancy. There is only one ASM file stored in this disk group. Each disk has 6 ASM extents, and total of 24 ASM extents for this file. Now, let us add 2 new disks to this disk group. Oracle ASM will start disk group rebalance operation. It will move 2 ASM extents from 4 existing disks to new disks. It will move total of 8 ASM extents. At the end of disk group rebalance operation, ASM extents are evenly distributed across all ASM disks. Oracle ASM provides unlimited capacity for future growth, but ASM has some storage limits. Oracle ASM supports up to 10,000 ASM disks. Maximum Oracle ASM disk size can be 32 petabytes. Oracle ASM supports up to 511 ASM disk groups. Oracle ASM supports up to 1 million ASM files in each ASM disk group. Oracle ASM supports ASM files greater than 128 TB in size. Oracle ASM supports up to 320 exabytes of storage. In this session, we have barely scratched the surface of Oracle ASM Internals. Oracle ASM supports several advanced features such as intelligent data placement, scrubbing disk groups, ASM fast mirror resync, even read for disk groups, preferred read failure groups, mirror resilvering, replace ASM disks in a disk group,